Welcome back, Wildcats, to another amazingly exciting video that I know you've just been waiting for. All right, so if you would take a moment to pause your video and update your table of contents. All right, now that you've updated your table of contents, now I said I knew you were waiting because there's something I've added to the table of contents that I know you've been waiting for. This date right here, test one. So remember, all of your assignments need to be turned in before this date up until 100. After this date, then the highest you can make is a 70 on the assignment. So make sure you're getting those assignments turned in. Okay? All right. So before we get to inverse functions 8, page 8, we need to go back and review some notes from our foldable. So let's go back and turn to families of functions foldable 5. Okay, so I believe in the foldable video that some of the last page got cut off and some of this did. So if any of this got cut off, let me know and we'll review that in class. But for right now, let's turn to inverse functions. So the last section of your foldable. Okay, so let's just review a couple things. To find an inverse, that's f inverse of x. The graphical way is to reflect over the y equals x line, or f of x equals x. And the test for an inverse is a horizontal line test. Now that's graphical, okay? Now, algebraically, you switch the x and y. That's the key concept. For inverses, you switch the x and y values and resolve for y. And that's huge. That's the topic we're going to really hit on in the examples today. Other ways, algebraically, is use composition of functions to determine the inverse. And last, that looks like f inverse of x equals x and f inverse of f of x equals x. And another kind of mark here is when you're finding the inverse, or when you do the inverse, the domain and range will flip. Okay? An inverse function is kind of an undo or cancel. Okay? All right. So you've got your journal section of that foldable updated. Let's go on to the examples for inverse functions. So we're going to go on to section 8. So here is your example / note for inverse functions. So make sure you put an 8 at the top corner because that's going to go in on page 8 in your journal. All right. So first off, before we get started, these are actually, don't tell anyone I said this, but they're actually kind of fun to do. Okay. Define the inverse of a linear function. So first off, you change h of x to y. So y equals 2x minus 9. Okay. And again, the key here is you switch the x and y. So we switch x and y. Now we solve for y. So that's really the concept of algebraically finding the inverse. So to solve for y, we're going to add 9 to both sides. Notice that I did not put the 9 underneath the x, okay? Because x and 9 are different. This is a number, this is the letter x, okay? Negative 9 plus 9 is 0. Now, I'm going to rewrite this because in addition, I can write x plus 9 or 9 plus x. But I think it's going to be more efficient to write x plus 9. So x plus 9 equals 2y. And lastly, we're going to divide both sides by 2. Anything divided by itself is 1, so your inverse is y equals x plus 9 divided by 2. Let's look at one more example. All right, let's look at example number 2. Define the inverse of a quadratic function. All right, so first off, you change h of x to y. So that's y equals x plus 5 squared. And again, define the inverse. The whole concept of getting the inverse is you switch the x and y. So we're going to switch the x and y. And then solve for y. Okay, so the first step is we have to figure out what we do to both sides. Okay, so I want you to pause and think about what do you think you're going to do to both sides to start solving. Okay, so the first step is we're going to take the square root of both sides. And remember, when solving, you can do whatever you want as long as you do it to both sides because of the equal sign. Okay, now the square root cancels the squared. Okay, and so for those of you kind of watching the video and like, whoa, Mr. What in the world are you doing? Let's just put a side note here to kind of demonstrate what I'm talking about conceptually. What if I were to take the square root of 5 squared? So let's think about that. So that's the square root of 25, which we know the square root of 25 is 5. So what I'm hoping you see is that the square root cancels the squared. Okay, so now we do that, so then we get, now also an important note is that when you take the square root, it's actually plus or minus. Okay, so then, and that only applies to squared. When you do the cubed problem, that doesn't apply. Okay, only applies to square root. Okay, so that cancels, so you get plus or minus the square root of x equals, and we erase the equal sign. I'll show you in a second. You can leave space because then you get y plus 5. And I'm hoping you'll see here that our last step is to subtract 5 from both sides. This cancels, so you get plus or minus the square root of x minus 5 equals y. Now I put the plus or minus, but it's okay if you leave it without, for now. Eventually it's going to be very, very important. Okay, technically it's plus or minus, but you can get away with just putting the square root of x. Okay, I just wanted you to remember that technically square root is plus or minus, but for right now you can just get away with that. Okay, so there are examples of 1 and example 2. I'm going to leave examples 3, 4, 5, and 6 for you to try at home. Okay, with the understanding that, remember, when you come to class, I want you to be prepared and come with questions so we can have that class discussion, and so I can work whatever examples we need to, if I need to work them all, or just example 5, so I can clear up any misconceptions you might have. So that way, in class, you can move on to the assignment. So again, remember, I'm available during class. We can do this. You can come in first thing in the morning, during tutorials, during lunch, and we can answer any questions. Okay? So if you would, have a terrific inverse Wildcat night.